This session is all about the concept of net present value or NPV. Now, before we go ahead, make sure that you are comfortable with the concepts of compounding and discounting. If you're not, go through our previous tutorials, okay? Right. Now to start off, we know that the fundamental concept of time value is that money has different values at different points of time. So we can't compare or add and subtract cash flows which are at different points of time. So what do we need to do? We need to bring them to the same point of time or the present value. NPV is used when we want to find out the return of a series of cash flows. Okay, so that is condition 1, that there are a series of cash flows at different points of time. And the condition 2 is that, yes, as I said, we need to find out the return. So we have a series of inflows, we have a series of outflows which are occurring at different points of time, and we need to find out whether the inflow minus the outflow is giving us a return. In such a case, what do? We use the tool of NPV or net present value. Let's see how that is done. Right, so the example is that you're planning to invest in a flat where you have to pay upfront 20 lakh and 50,000, and after 1 year 50 lakh and 50,000. After 2 years you're able to sell the flat and you get 80 lakhs. On the face of it, what does it look like? Hey, I'm paying out 71 lakhs and I'm getting back 80 lakhs profit. So 80 lakhs are making a profit, but what we need to understand is that this amount is being paid out now. So we need to find out the equivalent of paying out 50 lakh, 50,000 1 year from now. What is the equivalent of it being paid out today? What is the equivalent of receiving 80 lakhs today? And then we need to add and subtract them to arrive at the net present value, right? Or the net of the present values of the cash flows. So we need to present value them. Okay, so far so good. But if we remember the formula of present value, it is the future value divided by 1 plus r raised to t. What is our r? Now, that's important to understand. So, if we look at this, yeah, it looks like we made a profit, but what is the rate that we're going to use? Now, we can look at it two ways. If we are using our own funds, right, to invest in this flat, then what is the rate we would get if instead of this apartment, we invested it elsewhere? Because obviously we want the apartment to give us a return higher than that. If I could put it in a fixed deposit at 10%, then I want this apartment investment to give me a return higher than that. Similarly, if we're going to borrow the money and invest in the apartment, let's say we're going to borrow at 12%, we want the apartment to give us a return higher than 12%. Therefore, the rate of discounting we use is a rate against which we can compare the return, comparative rate. That discount rate is either the cost of borrowing or the rate of an alternative investment. Okay, so knowing that, let's put down these cash flows year 0, year 1, year 2. We're using the negative sign for the outflows and positive for the inflows. Now, hang on, let me delete this. Okay, so let's put down the present values. 20 lakhs, 50,000 is already at the present. I don't need to do anything to that. What about this? Before that, I'm putting a discount rate, 10%. Yeah. Let's make it more visible and format it as a percentage. Okay. Now, so what I need to do is take this, divide it by 1 plus r and raise that to the time period t. Therefore, the equivalent of paying 50 lakh 50,000 1 year from now, the present value equivalent is 45 lakh 90,000. Okay, and let's use the same formula for the 2-year inflow. Okay, obviously the cell reference has changed. I'll just take this value, divide it by 1 plus R. In this case, we will raise it to 2, okay? Because T is 2 and the present value equivalent of 80 lakhs is 66 lakhs 11,000. Excel shows it in millions, so it shows 6.6 million. Let's add all of this up. This is the net present value. That is the net of all the present values. That is the net of all our outflows and the inflows. So, what do I get? I get 29,339, but more importantly, it's negative. So what does that tell me? It tells me that my investment in the apartment is earning me less than 10%. Right? So if I compare it to a 10% investment, it's worse. I'm making a loss. What if I compared it to a 9% investment? I may be better off. Yeah. So essentially, NPV is a tool which helps me compare the rate of return of this investment against another rate, right? So it tells me whether my return is higher or lower. In this particular case, it's lower. So lower than the discount rate that I'm using. I am earning less than 10% in this investment. So that is something again important to remember. NPV is not an absolute. You choose a discount rate which is relevant to you, and if the NPV is negative, the return is lower than that rate. If the NPV is positive, it's higher than that rate. Let me illustrate, yeah? So let me just change this to 9%, okay? What do we see? We see that the NPV becomes positive. So what does that tell me? The apartment investment is giving me higher than 9%. Lower than 10%, but higher than 9. Right? Now, every time we want to calculate NPV, do we have to find out the present value of each of the cash flows? No, Excel has a neat little tool for that. The function is NPV. Now, if I just type equal to NPV and open bracket, it asks me for the rate and the value. What is the rate? Yes, it is this discount rate. Okay. Important, take the rate either as a percentage, like I typed it in here, 9%, or as 9 by 100, which is 0.09. Don't just type in 9. If you do that, then Excel will multiply it by 100 to get the percentage. So make sure you either type the percentage sign after that or type it in as a value of 9 by 100, which is 0.09. So in this case, we've done 9% and we want value 1, value 2. What are these values? These are the future values. Okay. So I'm just taking the future values within the NPV function. What happens to this cash flow which is already in the present? We add it outside of the NPV function. We do add it, but we're not present valuing it. And there we go. We've straight away got the NPV. So we can use either the Excel function or do it manually. We really don't need to do it manually. We can use the Excel function. Just be careful that you enter the percentage correctly and make sure that only all the future values are within the bracket. Anything which is already in the present is outside the NPV function bracket. Once you do that, you get your present value, and we understand that if it is positive, it is giving us a return higher than the discount rate. If it is negative, it's giving us a return lower than the discount rate. Okay? We'll move on to another example now, which is a real life example to understand the concept of NPV. So Mr. Rao recently met an insurance agent and the agent told him about a policy. Now what do we see here? That if Mr. Rao pays a premium of 22,838 for a certain number of years, so we see cash flows over a period of time, then we will get a maturity amount of 13,75,000 after those 25 years. we can leave this out because in case of death, this is the sum assured. Essentially what we're trying to find out and help Mr. Rao is that if I pay for 25 years 22,838 and I get 13,75,000 after that, then is this an investment which is making it worth my while? We see the conditions are fulfilled, we don't know the return, we're trying to find that out, and there are cash flows over a period of time. So let us see whether this investment is worthwhile for Mr. Rao. Now let's move on to Excel, and we put down the cash flows here. So starting from today, he's paying 22,838. The outflows, so it's negative. And we go down, he's starting from 0, so up to 24 will be 25 cash flows, outflows. And a year after that, he's getting the sum assured, which is 13,75,000. Now, obviously, we need to present value all of these. We can just use the NPV function to do so. What is the rate that we're using? Now, I'll give you two situations. What do we need? Which is the situation we need to use? Do we need to use the situation of borrowed funds or own funds? Well, obviously, it's own funds because Mr. Rao has an option of investing somewhere else. He's wondering whether to invest here. Now, let us assume, therefore, going back to the example. So, let's assume that he is able to earn 7% on another investment. Okay. So, he has an option of putting it into a recurring deposit for 10 years, 15 years, and that is going to give him 7%. So, obviously, he wants to know whether he's making more or less than this alternate investment. So, we will calculate the net present value using a discount rate of 7%. So, how do we do that? Yes, equal to NPV, and the rate is here. And the cash flows, remember, are the future cash flows. So it starts from this cell and it goes up to this cell. Okay, and don't forget, outside the NPV function, we are going to add the first cash flow, which is already at the present, right? Okay, and what is the NPV? It is negative. So what does that tell us? It tells us that this insurance investment is giving us a return less than 7%. Let's play around a little here and see, is it giving us, for example, less than 6% as well? No, it isn't. At 6%, the NPV is positive. What about 6.5%? At 6.5%, it's negative. So what we are seeing is that it's giving us a return which is somewhere between 6 and 6.5%. All I need to do is really increase the decimal place. This is 6.5%. So Mr. Rao may still take a decision that since it's also giving him a cover against death, that he may still be willing to go ahead and invest, but at least now he has an idea that it's giving him a return of between 6 to 6.5%. Otherwise, he would not be able to calculate the actual return of this series of cash flows. Okay, so that's really the understanding that we get by using the tool of NPV. We will now look at yet another example which will help us to understand what XNPV is. Okay? We have seen examples where cash flows were occurring at regular intervals. But how do you find the NPV when cash flows are occurring at irregular intervals, and that can very often happen in the case in real life, right? So here's an example. Now, you're given the cash flows. A company has estimated the cash flows for two projects, A and B. And you will see the cash flows, okay? Now, for A and B, and we have to find out which one to invest in. Now, I just want you to note something interesting, right? The cost of borrowing, that is the company is investing in either A or B, using borrowed funds where it is paying interest of 10%. Now, something interesting, as I was saying, is that if you do an arithmetic addition of the investment, and what the project is giving, that is the outflows and the inflows for both the projects, you will find here the outflows 3 plus 5, 8 lakhs, and the inflows 12 lakhs. This case also 8 lakhs and inflows 12 lakhs. So what you will find is that while arithmetically they are the same and they are happening roughly over a similar period of time, but there is a difference in the profitability or the return of A and B. And why is that? We'll come to that later. So let's check, how we will calculate the NPV for both of these. So I'm opening my Excel sheet. I have the cash flows. These are my negative cash flows. So for the first one, it's at periodic intervals, no problem. We'll use the NPV function. So NPV, that's NPV, open brackets. I'm taking all the future cash flows and I'm adding the present cash flow. Outside of that, I have missed the rate, So here's the rate and there you go. And what is the NPV? It's 2,32,204. Right. Now, what about project B? It's at irregular intervals. Well, the way we can find NPV here when there are irregular intervals of time is to use the Excel function of XNPV. Remember, we're finding out the NPV, but the Excel function we are using is XNPV, which is used for irregular intervals of time. The interesting thing about XNPV is if you take the XNPV function, you have to include the present cash flow also. So you have to put in the rate, which in this case is the same. You have to take all the values starting from the present and you have to take the dates. Because obviously we don't have data that it's recurring at a specific period of time. So we're taking the dates, obviously take it in the same direction, F8 to F12, G8 to G12. We've done that, close the bracket, and what do we get? It's a higher NPV. Now what we see here, what is our understanding is that both of these projects have a positive NPV. Correct? So, first of all, our first lesson is that if we were to write it down, is that both projects, let me increase the font size here. Both projects are earning more than 10%. However, project B has a higher NPV. Therefore, it is earning more than project A. And why do you think that is happening when both the arithmetic additions are the same? That is a beautiful example of time value of money. You will see here that we are getting a return on 3 lakhs or 6 lakhs barely about 7 months after our first investment. So on an annualized basis, the percentage return would be even higher. While here we are getting an inflow only after a year and it's much less. So the longer you delay your inflow, the lower your profitability. And if you will see, let me just show you how the NPV will come down. So let's say make this 4 lakhs, and I will make this 8 lakhs. So it's still 12, but I'm delaying the inflow. So I'm making this 4 lakhs and and I'm making this 8 lakhs. So I'm putting 2 lakhs of what I was getting here, I'm putting it later on. Look at that. So the NPV has come down, to 245,944. It was earlier 295, and now it is 245. So what you see is that money has different values at different points of time, and And in this particular case, because there are irregular cash flows, we use the function of NPV. The other thing that we learned is that if you delay your inflows, your profitability goes down. That's a lesson to be learned even when we are investing. The earlier we invest personally, the higher returns over a period of time. But anyway, coming back to the point, we need to therefore understand that we use the concept of NPV when there are cash flows at different points of time, and we need to figure out whether these series of cash flows is giving us a return higher or lower than our discount rate. We use an appropriate discount rate, either an alternative investment or a cost of borrowing. And if NPV is positive, we are earning more than the interest rate. Remember that NPV will give you a comparative return. So more than the discount rate. If NPV is negative, we are earning less than the discount rate. And if there are irregular cash flows, we use the XNPV function in Excel. If there are regular cash flows, we use the NPV function in Excel. Okay, I hope this is clear, and we shall talk about IRR next. Thank you.